Alright guys, let's do number 53. Let's get started. Your grandfather is a co-pilot of a bomber flying horizontally over level terrain with a speed of 275 meters per second relative to the ground at an altitude of 3,000 meters. So let's draw that. So you have a plane that's oh, this is a big fat problem. And I'm going to call that the initial velocity y naught, and that y naught is going to be at some altitude at 3,000 meters. And you have the speed. You have a plane. I know this is kind of whatever. So this plane has a speed of v naught, and this plane has the speed v naught, and v naught here is going to be 275 meters per second. All right. So the question is asking, so the bombardier releases one bomb. How far will the bomb travel horizontally when it's released on impact on the ground? All right, so this is pretty straightforward. So think about it this way, folks. You have a plane that's going to release a bomb. Once that bomb is released, it's going to carry that initial horizontal motion, which is 275 meters per second. That's always going to be a constant motion. And part of the motion is the horizontal motion and the vertical. And that's really it. Anyways, let's solve this. So let's set up the motion here. Firing from the people on the ground, it's suddenly, okay, wait. Oh, part A. How far from the bomb? Okay, so let's find the time it takes for this plane to reach 0. And I'm going to use the vector notation that you guys like. So I'm going to write x, the position x, or the r of x in terms of in the I hat direction, plus y in the j hat direction. And we want to find the time it releases. We want to see how far this travels. So we're going to call that x. So let's call this x. And x is really just going to be v naught times the time it takes. That's it, folks. So depending on the time it takes, that's x. But we're going to find this specific time where y is 0. So the equation for here would normally look like this. V naught y equals, we're going to call this y naught at some initial height minus gt squared over 2. That's really all the motion. And we're going to let y be 0. So this is going to be, so this is just going to be the time it takes for so we're going to let we're going to find the time it takes for this to fall at that height, and that time is really just going to be 2y naught divided by g square root, and there we go. And we're going to take that equation and we're going to plug it into this equation. So that means that x is really just v naught times the square root of 2y naught over g. That is part A, folks. That's all they're asking. So for part A, the bomb gets released. Let's find the time it takes for the thing to travel at some initial velocity. So I'm going to use my calculator. I'm going to store everything, which I might have already done that already, but let me do it again. So that's g. I'm going to take the square root. So I'm going to take v naught, the square root of 2y divided by g. Store alpha x. So here x is going to be, and I'm going to convert everything. So I'm going to convert this into 6,000.80 kilometers. And that's it, folks. That's all they're asking. So that was pretty straightforward. Let's see what part B is asking. Firing from the people on the ground suddenly incapacitates the bombardier before he calls bombs away. Consequently, the pilot maintains the plane's original course, altitude, and speed throughout the course. So that's another way of saying that the plane is traveling always at horizontally at that speed. So if this plane releases the bomb, that means that this bomb is going to travel at the exact same velocity component that the plane travels if it maintains its course. So where would the plane be when the bomb hits the ground? Well, the plane would just be simply right here, right at that target at y naught. So I'm going to say that the plane is going to be at the altitude where x is going to be 6.80 kilometers and the altitude is just going to be 3 kilometers. So it's just going to be right on top of the thing. So now let's part C. The plane has a telescope bomb sight set so that the bomb hits the target seen through the sight. Moment at one angle from the vertical was the bomb. So let's think about it this way, folks. So it's asking for this angle. And this angle, think about what this angle is. This angle, what we're going to be doing is we're going to take the x divided by the y to get that angle where it faces that target. So that angle right there is nothing more than, that's going to be tan of theta. It's just going to be x over y naught. And to get that angle from the vertical, so I'm going to say, so did I store everything? Yeah, I did. So x divided by y would be 66.2 degrees. And that was a pretty easy problem, to be honest. I mean, it's blue, but it wasn't really hard at all. So anyways, folks, I hope you enjoy. I hope this helps you guys. All right, bye.